Calculation of oxidation number. In this lesson, we will learn a set of general rules for calculating oxidation numbers of some elements in compounds. First of all, let's see what is oxidation number. Oxidation number is defined as the number of electrons donated or accepted by one atom of any element in a molecule. That number of electrons is called oxidation number. Let's consider a compound aluminum chloride. In the formation of aluminum chloride, aluminum donated 3 electrons. That is why its oxidation number is 3. Here there are 3 chlorine atoms. One chlorine atom accepted 1 electron, another chlorine atom another electron, and another chlorine atom another electron, and chloride ions are formed. So in this compound, number of electron accepted by one atom of chlorine element is its oxidation number. So here oxidation number of aluminum is +3. Oxidation number of chlorine is not -3, because in definition it is said number of electrons donated or accepted by one atom of any element by one atom. So here one atom of chlorine accepted one electron. That is why here the oxidation number of chlorine is -1. So this is oxidation number of electrons donated or accepted by one atom of any element in a molecule is called oxidation number of that element, and oxidation number is written at the top of the element in the molecule. Now let's see the general rules for calculating oxidation numbers in detail. Oxidation number of elements in ionic compounds. Ionic compounds, suppose sodium chloride. Here oxidation number of sodium is +1, because in this compound sodium donated 1 electron and chlorine accepted that electron. That is why oxidation number of chlorine is -1 here. In this way, we can say that oxidation number of group 1A elements like sodium, potassium, etc., oxidation number is +1, and group 2A elements like calcium, magnesium, etc., oxidation number is +2, and group 3A elements like aluminium, oxidation number is +3. That means normally these elements, alkali metals, donate 1 electron. That is why oxidation number of these elements is +1. Alkaline earth metals normally donate 2 electrons. That is why oxidation number of these metals +2. Group 3 element aluminium normally donates 3 electrons. That is why oxidation number of aluminium is +3. Similarly, oxidation number of 7A elements like fluorine, chlorine, bromine, iodine, etc. Oxidation number is -1. Oxidation number of oxygen, that means group 6A element, is -2. The compounds, ionic compounds formed by these elements, alkali metals, alkaline earth metals, or elements belonged to 7A, 6A, the oxidation numbers are this type. Now let's see oxidation numbers of elements in covalent compounds. Oxidation number of elements in covalent compounds. For example, a covalent compound HCl. Here, no donation and no acceptance occur. Nevertheless, electronegative element get negative oxidation number and electropositive element gets positive oxidation number. Here, electronegativity of chlorine is 3.0, hydrogen is 2.1. So, chlorine is a higher electronegative element than hydrogen. That is why here the oxidation number of hydrogen is +1 according to the valency of hydrogen, and chlorine is -1 according to the valency of chlorine. So in covalent compounds, electronegative atom will get negative oxidation number and electropositive atom will get positive oxidation number. Similarly, in ammonia, electronegativity of nitrogen is 3.1, hydrogen is 2.1. So, electronegativity of nitrogen is higher than hydrogen. That is why the oxidation number of nitrogen is -3 and hydrogen is +1 by one atom of any element. This is the oxidation number. This is actually here +1, here +1, here +1. So by one atom is oxidation number is +1. This is about oxidation number in covalent compounds. Now let's see oxidation numbers in interhalogen compounds. Electronegativity of halogens are fluorine 4.0, chlorine 3.0, bromine 2.8, and iodine 2.5. The first compound is iodine chloride. Since chlorine's electronegativity is higher than iodine, so oxidation number of chlorine will be -1 and iodine will be +1. Here +1, here -1. Another compound, iodine tribromide. Here, electronegativity of bromine is greater than iodine. So, bromine's oxidation number will be negative, that is -1, and iodine's oxidation number will be +3. Iodine donated 3 electrons, that is why +3, and these 3 electrons are accepted by 3 bromine atoms. So oxidation number of each bromine will be -1. So here +3, here not -3, it will be -1. This is about oxidation numbers in interhalogen compounds. Now let's see some oxygen compounds in which the oxidation number of oxygen atom. some oxygen compounds. First of all, let's see about peroxide. Here, hydrogen peroxide, oxidation number of hydrogen is +1 and oxygen is here -1, because hydrogen donated two hydrogen atoms donated 2 electrons, and these 2 electrons are accepted by 2 oxygen atoms. So one oxygen atom accepted 1 electron. So oxidation number of oxygen will be -1 in peroxide. Let's see another peroxide, sodium peroxide. Here oxidation number of sodium is +1 and oxygen is -1. So in peroxides, oxidation number of oxygen will be -1. Let's see one normal oxide. Normal oxide is sodium oxide. Here oxidation number of sodium is +1. Alkali metal undergoes oxidation number +1 and oxygen is -2. 2 sodium atoms donated 2 electrons, and these 2 electrons are accepted by 1 oxygen atom. So here oxidation number of oxygen is -2. Now let's see one superoxide, that is potassium oxide. Here one potassium atom and 2 oxygen atoms. Oxidation number of potassium is +1 because this is an alkali metal, so its oxidation number is +1. That means here potassium donated 1 electron. This 1 electron is accepted by 2 oxygen atoms. So 2 oxygen atoms accepted 1 electron. So oxidation number of oxygen will be -half. So here oxidation number is -half. Oxidation number may be fractional, but valency cannot be fractional. Now let's see variable oxidation states of p block elements. Oxidation numbers of p block elements. Let's consider a molecule ammonia and another molecule nitric acid. P block element here shows variable valencies. In this compound, oxidation number of nitrogen is -3, and here oxidation number of nitrogen is +5. Now let's see how nitrogen shows these variable valencies. Electronic configuration of nitrogen is 1s2, 2s2, 2p3. Here the electronic configuration is in the box system like this. 2 electrons in the s orbital, 3 electrons are in the p orbital. So in the outermost shell of nitrogen there are total 5 electrons. So maximum oxidation number of nitrogen is 5, and in the outermost shell there are 3 unpaired electrons. So the oxidation number of nitrogen is minimum 3, maximum 5, minimum 3. This is oxidation number from electronic configuration of p block element nitrogen. Let's see another compound of p block element. The compounds of sulfur are sulfuric acid and hydrogen sulfide. Here the oxidation number of sulfur is -2, and here this is +6. 2 is the minimum oxidation number of sulfur, and 6 is the maximum oxidation number of sulfur. It is determined from electronic configuration of sulfur. Sulfur 16, 1s2, 2s2, 2p6, 3s2, 3p4. In the outermost shell of sulfur, in the s orbital there are 2 electrons, and in p orbitals total 4 electrons. So in the outermost shell of sulfur there are 6 electrons. So this is the maximum oxidation number of sulfur. And in the outermost shell total number of unpaired electrons is 2. So minimum oxidation number is 2. That is why in hydrogen sulfide oxidation number of sulfur is 2, minus 2, and in sulfuric acid oxidation number of sulfur is plus 6. This is minimum oxidation number, this is maximum oxidation number. Let's see another compound of p block element. Now the compounds of chlorine are perchloric acid and HCl. In this compound, the oxidation number of chlorine is minus 1, and here this is plus 7. Chlorine's oxidation number, minimum oxidation number is minus 1 and maximum oxidation number is plus 7. This is discussed according to electronic configuration of chlorine. Chlorine 17, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. Outermost electronic configuration is 1s orbital and 3p orbitals. Here there are 2 electrons, and in p orbitals total 5 electrons, 1, 2, 3, 4, 5. So in the outermost shell of chlorine there are total 7 electrons. So this is the maximum oxidation number of chlorine, and in the outermost shell there is only one unpaired electron. This is its minimum oxidation state. So this is all about oxidation numbers of p block elements that show variable oxidation numbers or oxidation states. Now let's see oxidation numbers of some elemental molecules. Some elemental species and their oxidation numbers. Suppose oxidation number of sodium is 0. This is atomic form, no donation and no acceptance of electrons. So this is 0. Similarly, iron 0, magnesium 0, like this. And some elemental molecules like chlorine, here oxidation number is 0. This can be written here 0, 0, 0 at the top of the species 0. Similarly, bromine 0, iodine 0, etc. And some polyatomic molecules like ozone, oxidation number is 0. We can write here 0. And another molecule sulfur 8, here oxidation number is 0. That means we can write here. So in these elemental species or molecules where there is no donation or acceptance of electrons, that is why in these molecules oxidation numbers will be 0. This is all about general rules for calculating oxidation numbers. Now today, thank you very much.